Hi, welcome back to our AP Stats notes. Today we're going to look at homogeneity. So we're testing to see if the different populations have the same proportion of individuals with some characteristics. So testing to see if different populations have the same proportion or percent of individuals with some characteristic. So again, we need to find expected counts and to find our expected counts. That's not what I wanted. To find our expected counts, what we're going to do is we're going to take our row total times our column total, and we're going to divide that by the grand total of observations. All right, so what we're going to do is we're going to do our chi-square test for homogeneity, and just like always, we're going to assume the null hypothesis means that there's no difference in the population's proportions, and our alternative is going to be that there is some difference. Okay, so we need to calculate our chi-squared test statistic. And we need to also check, so maybe I'll put this over here, 1, calculate the chi-squared value or test statistic. 2, we're going to conclude whether to accept or reject the null based on the p-value. We should also make a quick note here. You need to check randomness, the 10% rule, just to make sure we got all our bases covered. So I want to check if there's convincing statistical evidence that there's a difference in the distribution of college planning across the 4 grade levels. So we're going to check out our totals. So our totals here are going to be 44, so we got 44, 56, and we surveyed 100 students. So here we get 25, 25, 25, and 25 from each. So our null hypothesis that there is no difference in college planning percent between the grade levels. And then, of course, the alternative is going to have to be there is a difference in the percent of students who, or in the percent of, I should say, college planning between the grade levels. So what we're going to do is we're going to calculate all the expected counts. So what I'm going to do for the freshmen is I'm going to multiply I would multiply 44 times 25, and that's going to get me, if I divide by the total of 100, that'll give me what I need. So let's do this in red. If I wanted freshmen, yes, I'm going to do 44 times 25 over 100, which is the row total times the column total divided by the grand total. And if I do that, I'm going to get 11. For the sophomores, I would do, again, 44 times 25. And you'll notice that I'll get the same thing because it's still 44 times 25. I'll get the same thing for the juniors and the same thing for the seniors. If I want freshmen no, what I'm going to do is I'll use the 56 and the 25. So 56 times 25 divided by 100 would give me 14. And then I can do the same thing for the sophomores. And I'll get the same answer because it's still 56 times 25 divided by 100. And for the same reason, I get 14 for the last two. So what I've got here are my expected counts. And then if I wanted to calculate the chi-squared test statistic, what I can do is I can add up. That's not what I wanted. My chi-squared is going to equal the sum of, I'm going to find the difference from the freshman yes from the observed and the freshman yes from the expected. And I'll do 3 minus 11 squared divided by 11. So it's observed minus expected over squared over expected. And then I'm going to do the same thing with the sophomores. Yes. That'd be 12 minus 11 squared over 11 plus, and then I'll keep doing that until I get to my very last one, which is the bottom right corner. That would be 10 minus 14 squared over 14. And if I do that, I'm going to get 14.6. So there's my chi-squared test statistic. What I can do with that is use my solver, and I'm going to do 0 equals the chi-squared CDF, 0 0x degrees of freedom, which you'll remember is the row total minus 1. Sorry, the number of row variables minus 1 times the number of column variables minus 1. So our degrees of freedom would be 4 minus 1 times 2 minus 1, which is 3. So I'll do 0x degrees of freedom. That ends up being chi squared CDF 0x 3 minus, and then I'm going to find out what is my alpha level. And once I get my alpha level, then I can, let's say it's 0.05. I'll use my solver to solve for the chi-squared cutoff value, and then I'll test my 14.6 against that cutoff value.